it is being recorded. You can access the recording at the link after, and we'll put it up on YouTube after the fact. There is a chat on the side where you can message and chat. There's also a little question answer box on the side. So if you look on the side and you see a little box with a question mark on it, that's where you can type in questions. We'll use those questions to prioritize what to answer at the end. So in terms of the format, we're going to do roughly like 8 minutes from each of the presenters. And then just question answers at the end. We'll prioritize the ones that get the most upvotes, basically. So write your questions there, upvote to the ones that you like and want to hear answered, and we'll go through those. Please keep the questions on the topic of agents in production. LangChain covers a lot. We'll be talking about agents in production today. If there's another topic, we'll do a webinar for that in the future. Maybe we can start with some quick introductions from everyone and then jump right into it. So Sam, do you want to do a quick intro?
Sure. Hi, I'm Sam, and I've been working on basically a personal assistant built on top of LLMs for about 6 months, and previously have done some contributions to LangChain in the areas of memory, vector stores, other things like that. For the past few months have been building with agents, and we'll share kind of some of two specific techniques that I used that kind of helped with performance pretty early on for me.
Awesome.
Nice to meet you all. I'm Dev. So until recently, a third-year PhD student at Stanford, doing a lot of reinforcement learning NLP. I'm currently taking a 1-year leave, potentially dropping out, working on Multimon, which is like a AI personal assistant that can take actions in the browser for people.
Great. And Devin?
Hello, I'm Devin. I was previously led engineering at an ML startup in the automotive space, kind of everything but self-driving, and have recently been working in the agent space, specifically trying to use LLM's understanding of code to do everything that is not coding. So helping engineers with all the tasks in their day-to-day that aren't coding that requires an understanding of code.
Awesome. So let's get right into it. Sam, do you want to start?
Cool. So I will share my screen. Everyone see this?
Yep.
Cool. So I'm going to talk about 2 things. We only have 8 minutes, so I'll go over it pretty quickly. And then if folks have questions, you can dive into one of the 2 specific things. So setting the scene, and excuse, of course, my poor slide design. So we were working on a personal assistant that a user interface with via conversation. And so our tools we're using were primarily APIs. We did not do a lot with CodeGen. The format of the agent we're using was very similar to the React format: thought, action, action, input, observation, although we did a fair amount with like multi-action inputs and outputs as well. I wanted to talk about 2 specific things that we did. Again, if this has already been kind of, I haven't been following like the auto GPT stuff as closely, so maybe some of this is common knowledge, but I'll say it. So tweak number 1 that helped. If you have been running agents, you'll see a lot of things where sometimes you'll be like watching them console log as they go off into some rabbit hole, and you're like, no, why are you doing that? Please undo. So one thing that we integrated early on that was helpful, especially when a user is kind of watching the agent, is a way to give it real-time feedback and adjust its course as it's actually processing the thought, action, action, input loop. So I'll give an example. This is very early screenshot, very end UI. My co-founder, who's a designer, was very upset that I wanted to share this. So this is, you'll see an action here. And basically I'm using my calendar and I'm kind of talking to the agent as it's going. So you'll see I ask it a question, and then the second follow-up is kind of a like edit to the question. And so you'll see here kind of mid-screen, there's a log of user feedback. And then based on that, it thinks, okay, I'm going to check her text instead of her calendar. Because I see that it started by checking my calendar and I'm like, no, it's probably not there. And so then I'm continuing to give it some feedback as it goes, and it's kind of like a two-way process where it's looking something up and I'm talking to it. And so that is like one thing we saw basically, and a little bit on the concrete implementation, and I can show these slides after. So what we did basically was had like a stream, another WebSocket that the user could kind of send communication to while the agent was running, and it would write to a Redis store. And then in the actual executor loop, before it went on the next planning stage of the loop, we would read from the Redis store and see if there was any like new information in the feedback store, and append it to the planning, to the intermediate steps before we actually went and like did the next planning stage. So implicit in that also is that we would update the prompt to introduce the idea of user feedback and how to respond to it. So we'd say like, here's a special tool, user feedback, like if you see that the user has said like some new information, then you should probably like pay attention to it more than your past observation. And so this was like a nice trick for us to kind of get out of that rabbit holing behavior. Okay, second concrete
Sam,
thing.
one quick question I have there is, so I think in Auto GPT they don't have this. I think this is really cool, and I think a lot of people are are excited about it. There is the concept of like at each step you basically ask like, do you want to continue or something like that. Did you consider that, and like what were the trade-offs that you kind of like weighed from both like an engineering or UX decision?
I think it's also, we did consider that. It's also a little more frustrating to constantly be like, yeah, I want to continue. Yeah, I want to continue. So this was a little bit more of like user opt-in driving the agent, just to make it feel a little more seamless, like you're kind of communicating with it while it's in its thinking state. Cool. Next one. So this is the next one we did, and this was heavy use of a router agent. And so we started out kind of with like basically like a whole bunch of tools, right? Like there was like create, retrieve, update, delete for like every single API we were doing. And the agent quickly ran out of space in the prompt. And so we tried a couple things. Our first thing was like maybe at every like step, they're going to guess which tools to use. But we saw like in practice that sometimes it did a poor job guessing, especially when there's like a ton of different tools, basically. Like it couldn't necessarily guess the right ones every time. So we decided to think about the product flows that our user was going to experience frequently. And we tried to basically constrain the agents into different templates. So decide like, okay, if this is a scheduling agent, it probably needs calendar retrieve, calendar creation, and maybe like a user's scheduling preference thing. So you can see here on the right, this was like an iMessage integration we experimented with. It has like these product specific tools, which are actually agents themselves, that are more aligned to like what the user is trying to do. Here's kind of the code for this is more complicated, but here's kind of two examples of templates that we used. So here you'll see like if I'm trying to look up, we had a context on person tool, which basically if I like gave it a person's name, would use, if you see the tool set down here, like recent email search, contact search, internet web page search, and internet search. And so this would do like a deep dive on writing a bio of a person with my personal data and also email or internet access. And so these specific tools were really well suited for this product flow. And so here's the second example, schedule meeting or event. You'll see here there's like some instructions that are specific to this and a tool set that's specific to this. And you can see here the tools also are well constrained for everything you would need to schedule. We also found, so the tool set choice is important, but also giving this template, like the agent, like specific instructions about how to deal with different scheduling cases really improved performance here, or different lookup cases. We basically didn't want the agent to have to reinvent the wheel every time it encountered a scheduling event, a scheduling task. We don't want it to think from first principles, like, okay, like what is a calendar? How should I use it? Like give it a little bit of help and give it a little bit of a nudge on like which tools were well suited. So specific implementation for this, we use the conversational agent as a top level, and then the template names and descriptions are themselves tools. And I also added a fallback dynamic agent, and then that would do like an LLM inference to predict which tools were relevant to the user's query if they didn't fit into any other agent descriptions. And this is, and then this would basically kick off a background task which runs the agent, and then return a conversational response to the user saying that that agent was started. Cool.
So the routing logic. So the routing logic that you had was the conversational agent itself, basically, and yeah.
Absolutely, yeah. So, and then for the experience for the user, the nice thing about backgrounding the agent was then like you could keep talking to the conversational agent, and like it would be like, okay, I started this background task agent that's running. Like you can follow along here, maybe put it in a different thread. There's like a lot of UX choices you could do. But then like it ended up feeling more organic to have this like main conversation which would control the other agents being spawned basically, and that those agents would be really custom to those specific tasks helped their performance. I think, yeah, that's all I have. So pause here, we can do questions at the end.
Yeah, and unless Div or Devin have any questions, maybe we can move on to Div's presentation.
Sounds good.
No questions, I guess, Sam. I'll be talking about something similar, like this routing layer I found is incredibly helpful as well. Even just not even like for the LLMs themselves, but like from an engineering principle perspective, like helps simplify the problem a lot, which, you know, agents are pretty complex. So breaking it down into these user workflows helped me as well.
Yeah, definitely. I would say like also planning, I think these are very useful, where you can just like make a plan over different tools and then use them. Cool, let me share my screen. Cool. Can everyone see this?
Yes.
Okay, nice. Cool. So let me start. So yeah, so this is multi-on. I can start with the demo. See if it's working.
Introducing Multi-on, your AI web copilot. Well, what can it do? Literally anything. Let's ask it what the weather is today. Then it can control your browser and then simply Google to find what the weather is. Similarly, you can ask it to say order a burger from DoorDash. There it can go, open DoorDash, select your favorite burger, add it to the cart as well as checkout. And there it goes, places the order. It can also automatically post on social media, including Twitter for you. That's Multi-on.
Right, cool. Yeah, so that's sort of our intro demo. And I can first go into like sort of like talk about the high level sort of the problems we're trying to solve and what Multi-on can be used for, and then like do more of a technical deep dive later.
Introduce.
Yeah, and this is me holding a. Yeah, okay, missing that, but yeah, there's a photo of me holding a burger that I ordered. Cool. And yeah, the goal is like you want to sort of be able to have a browser assistant that people can use in everyday life. And a lot of it's about like productivity and like context switching, and we want to save time in like say like ordering, sending emails, scheduling, flights, etc. And autonomous AI agents are very useful for these things because they can run automatically. The problem with autonomous agents is like reliability and do they have actual use cases, and what do you do if they fail? And if anyone has used AutoGPT, the problem is like it sucks actually, because more than 90% of the time it fails. It doesn't have actual use cases. It's really unreliable. It's very hard to connect it with different things, and has zero personalization. And I think like these are the things like you want in like if you have some sort of like browser assistant. And this is like where like this is what you need for an agent to work in production, and that's what Multi-on tries to target. And you can actually use Multi-on on different platforms. So we did this experiment. This was actually for a hackathon where it can like we got it to work on a mobile app, and you can send a message to Multi-on, which is say running on a laptop or on a cloud somewhere. and it can fulfill this order for you. And here we actually use a multimodal model, so it can analyze the image and find what the ingredients are. And then this kicks off our agent that's controlling the browser, and then it goes and places the order. Yeah, and then can find a salad which is very close to the original one. Okay, then we'll try to move a bit fast because there's might be a bit too many demos. And you can also use this for the ChatGPT plugin ecosystem. So this is a new interface we are exploring currently, and we are planning to launch this publicly in like a couple of weeks, where anyone can just use the Meltdown plugin direct ChatGPT to automate a lot of web tasks. And this can sort of enable you to make calendar events and yeah, so it's pretty powerful, and you can use it on like DoorDash, Amazon, emails. We even got it to work on like AWS, for example. So like almost like it's very horizontal, so it works on a lot of different websites. Cool. And yeah, and you can do it for a lot of other things too. So let's try to move on. Let's see. And I think I already showed this. I think it's got repeated, unfortunately. You can also use it for coding. So we can use it to write code on, say, Google Colab, potentially VS Code. You could use it on GitHub. And so I will say the nice thing about any sort of web-based browser assistant is it's very general, and you can, we have this parsing and prompting logic, which the same thing can work on every website. So we don't have to do anything for it to work on any website out of the box. And so it just generalizes really well.
Are you parsing the DOM, or is it like image-based as well?
So currently, I would say we are mostly parsing the DOM. So we started with text-based, and what we are doing now is we are adding OCR for a lot of icons, a lot of images, so especially if you are on say say DoorDash or something, want to order food, then we can identify which one is more appealing to a user potentially, or what a user might prefer. This is one example where I actually got Meltdown to edit its own AWS backend. So I went to GPT-4 and GPT-4 gave me a step of instructions, and I pasted those instructions into plugins and said execute those instructions using Meltdown browser, and then Meltdown can go and make changes. Yeah. Funny thing is we accidentally crashed the website because I was playing with it at late night at 1 a.m. once, and someone messaged me in the morning, "Oh, your website is down." And so I think that's the thing with agents is you need to be, in a sense, be able to observe them and make sure if they're working autonomously, you don't end up making a mistake, and have a way of monitoring and ensuring reliability.
So how do you do that now? Is that mostly on the user to look at what's going on in the text box and look at it that way?
Sure. So I would say so one is we have the text box basically for user interpretability. So the user can see, okay, this is the current command, this is the current response, and they can override it by they can pause the execution, give it a custom command, and so that's the current way to do the things. And we are trying to add a critic to the loop. So similar to what AutoGPT does, where every time it takes an action, we'll have a critic agent criticize, okay, why this might have been wrong or how you can improve it. And we've seen that improves the accuracy a lot, but it reduces the it increases the cost. It also like increases the latency of the system. So we have to be a bit more careful about when we're running this in production. We need it to be like really snappy for a user. So how do we like optimize between like accuracy versus like making it fast? And I think different use cases, you can like use different combinations of architectures and like combination of different like planning and criticism. And I think where we might go with this next is like we might build like say like evals or like benchmarks, and like if you want to run this something, you can then like sort of like look at those. Okay, like yeah, this is like really reliable on this task, and then sort of like you know, okay, like this won't cause an issue. We are also working on building like a authorization system. So like currently Multion can control any website you're logged into, but we might provide a panel which allows you to like say like, okay, like it's only authorized to work on Amazon, or it can only do like read task on Amazon, but not write. But now you can be like, okay, like now you're allowed to write, and then you can control which sites it's allowed to like write on or not. And that way we can ensure like, okay, like it's not doing anything that you don't want it to do. And how internally Multion works is we use like a very compressed DOM representation. So we have a custom parser that can take the whole HTML and simplify it a lot. We have some multimodal elements where we do OCR and like sort of simplify icons to make sure we don't miss any elements. And we are actually able to fit like 90% of the websites in less than 2K tokens. So this actually like works pretty well.
How much are you changing that parser? Like, is that something you guys are constantly iterating on like every day, or is that pretty standard and fixed at this point?
It's pretty standard. I will say like currently it's one parser for every website. Like it's like the same parser for every website. And sometimes it happens like, okay, like some websites have really messed up DOM elements, or they have some like really weird issues. There we might have to like sometimes make some like minor changes, like to make it sure like, okay, like we didn't miss this particular like weird looking DOM kind of thing. So I think those are the current like bottlenecks where like this could work, say like 95% of the websites, but like for the remaining 5% of the website, you might have to like customize the parser of that or like use other tricks. And I think in the future, we'll probably replace all of this with like an AI model. Current issue is like context lengths, because like it's not possible for you to fit the context length of the full DOM into an AI model. So it's very hard to do this directly. And also latency, I guess, is another issue. Because like this works really fast, like less than 10 milliseconds. But if you use an AI model, that will increase latency. So there are like a lot of ways to improve this over time. Yep, and that's basically Multion. And I can go a bit more onto like where we sort of like want to go, or where we see okay like agents going, especially in the production setting. And I think what we need is like I think also Sam also mentioned like routers are very important because they allow you to like use different tools, different like applications. And I think we will probably like converge to this sort of architecture where we have some sort of planner agent, which could be like a task engine that takes like a user task through a chat interface, has some sort of rules, can break down the task into like, okay, like these are the steps of the plan you want to execute, pass it to the router. The router can use like the web, that could be through the Multion, use like APIs, use some sort of personal retrieval, do the things, and the result back to the task engine or the planner, and then like sort of like do this process over time. And I think like this is just seems to be like a general system that you can like converge to in terms of agents. And I just call this as like a neural computer because it sort of resembles operating system to some extent. And I think like a lot of questions will be, how do you make this really reliable? How do you monitor? How do you observe? And how do you like make it specific to do different tasks? But yeah, that's it. Thank you. Cool. Any questions?
How do you handle if a user kind of inputs something that Multion can't handle?
Sorry.
In terms of like if a user says some, I don't know, I guess nonsensical thing or task it's unable to like
I see.
complete.
It's just I can't do this task.
Okay.
Yeah.
If you say like hi, how are you? What will it do? Will it like respond, or will it like can you have conversations with it?
Yeah, you can, because it's actually like currently we are using GPT for a lot of things. So by default, it will just act as a chatbot if it doesn't know what to do using the screen elements.
Very cool.
Very cool. One last thing I have is, I mean, like, so this reminds me a lot of like the Adept demo that came out kind of like a while ago. And so like, you know, they've raised like, you know, 350 million and are training their own like model. Like, how are you able to like what's going on? Why were you able to do something that at the surface seems similar? Or like, yeah, do you think it's similar? Are there like big differences that are missing? And like, yeah, like what's going on here?
Definitely. So I would say like one thing where they started from this, like they wanted to screen everything from scratch. So they started with like, let's collect our own data from scratch. Let's like hire like people in Philippines. Let's like try to solve this problem with our own spatialist architecture. And I think they just missed out that GPT-4 is already trained on like the whole of internet, and that's like good enough for most things you might want. So you just have like so many good pre-trained models out there that if you start using them, then you can just like fine-tune them or do like a lot of like prompt engineering or retrieval kind of stuff. And I feel like they were a bit too early where like prompting didn't even exist. So I think they just missed out on the whole space where they were just concentrating on the models. But I think the real question is like, how can you make this into a reliable system instead of building the best model out there?
Yeah, I mean, I think one common thing between what you and Sam have shown, and I'm guessing Devin will probably show as well, is it really is a system, as you mentioned. It's not really like a model. It really is a system of all these different components that are connected. And so the model is important, but it's just one part. All right, Devin, do you wanna take over?
Yeah. Let me try share my screen.
And
You see?
reminder to add questions in the question box. I see some good ones out there already, and so we'll start tackling those after Devin's presentation. And yes, your
Cool.
screen.
Okay, awesome. Just going to give some quick context before I jump into a demo. But as I said, I guess in the intro, what I've been really interested in is, can we use LLM's code understanding for things that engineers do that isn't coding? So customer support, documentation examples, writing examples, triaging customer support issues, and then also communicating kind of technical changes to non-technical stakeholders. These require engineers because of domain expertise, not just knowing how to code, but being able to navigate a code base, being familiar with the code base, and also knowing what has changed in a code base. This is a common of like any scaling engineering organization. Like, I also am, I guess, active in open source and have felt this as an open source maintainer. I think you can see this in LangChain's open source repository as well. I'd like, just checked this morning, there's like over 1,000 issues, 200 open pull requests, almost 50 issues in just the past 48 hours. Like, LangChain is probably one of the fastest moving teams in the space, but still it's hard to keep up with kind of the non-technical or just general requests that come around building a product or project. So can we basically accelerate product development by helping both contributors, so people put requests, give them the necessary knowledge and context to contribute, which is like often what maintainers are doing. Encouraging someone like, oh, that's a great idea. Here's a relevant file. Feel free to make a PR and I'll review. And then also like helping reduce the need for maintainers. So keeping code owners or maintainers informed and then only looping them in when necessary. So basically, more contributors, less maintenance overhead, in theory, more LangChain. So with that, I want to try to do a live demo. So we'll see how this goes. But so here's LangChain. I mean, I think everyone's familiar. Similar to what Sam was talking about, I've found as I've scaled this up. So a bit of background, like I originally built out a bot that could do this on a small test repository that I made. And so going from that in a cool demo video into something that actually works on a large repository, there's lots of interesting challenges that I can talk about that came up around that. But I want to keep it very focused on like one user workflow at a time. So this kind of routing layer. So right now, the way the bot works is it only focuses on what I call closed-end feature requests. So how do you, given a feature request that is about adapting the existing repository with not too much external information, can you find the relevant files and then tell the issue creator like how they could actually implement this? So one good example I found this morning of this is this ticket for adding support for regular expressions and character text splitter. pretty intuitive. Sometimes you want to split on something that is hard or dynamic, so you want regular expressions. And so I created a fork of LangChain and then filled out the same issue here. So in the background, this kicks off a job. Like once you install this GitHub bot, it'll index your repository and continue to re-index it as it evolves. So then hopefully, when I create this issue, this kicks off a job in the background. What that looks like is it pushes the event to a webhook, publishes it to a topic, which then runs a cloud function in the background, which basically kicks off this feature request agent to try navigate this repository, find the relevant files, and then suggest how the maintainer might go about making changes. So here's an example. So, it's fairly straightforward change. It looks like added a use regex flag, which is I think sensical, and then has a uses regex.split. So
So Devin, one thing you said was that this does everything except coding, but this looks like it's writing a lot of code.
Right, right. The distinction is, I think it's almost more of like a promise. Like this isn't. I'm not saying like, hey, copy paste this code or like this will be perfect, but here's a good starting point. And one thing that I want to talk about later is also like the way this is implemented is what I'm calling checkpoints. But basically, like if the model can't figure out how to change the code, but it thinks it's found relevant files, it'll just post like, here are the relevant files, or here are the similar issues you might want to check out. So the end game is like, how do you get that contributor as far as possible to like just making that PR in like a click of a button, right? So in this case, it's a simple change, and the bot was able to get pretty far. But yes, it is like, it's a funny thing because to like do all this, you need a good understanding of code, and then GPT-4 is really good with code, so it ends up just coding. Yeah, so this is one example. I also played with a couple other ones that are open issues. So one was kind of interesting, was this Weaviate vector store. Another one like adding operations to it for updating and deleting. And you'll see it came up with this plan about like, here you should add these methods, and then also remember to update the documentation, which is another thing. Like as like when you actually are like looking at a large repository, or like scaling up something from just like going from instead of 0 to 1, like 1 to n, there's often requirements or dependency changes that happen. So like if you update this thing, also have to update this example, also have to update this documentation, or kind of if it's used in other parts of the library, update that as well. Because this is about the issues of scaling. You'll see I like open and close this. One of the things that this runs into is like, there's actually like the reverse proxy I'm currently using to run this is I'm having timeouts after 2 minutes. So what this is actually doing is basically re-triggering the agent. I cache aggressively throughout the kind of process. So it just like resumes based off where it was last cached, resumes until it finally completes in within the 2 minutes. So I need to fix that. But and then another quick example of like, it's currently just isn't, like the error, like the kind of bug agent isn't implemented or fully, or at least roll it out. So, this just is ignored. So the agent's like, okay, I cannot handle this request, which if I switch back here, like, I think that's actually really important, is when you are, using these agents, like doing nothing is actually the status quo, right? So rather than doing the wrong thing, it's better to just do nothing, in my opinion, because otherwise you're going to just be creating more confusion potentially. So if you can't do a task, don't do it, is at least the philosophy I've been approaching this with. And then just, I guess, some slides already touched on most of this, but the main challenges, right, is when you scale up, specifically thinking about repositories or incorporating other data is much larger than context windows. Like when you're on a very small project, it's easy to navigate the repository. As that grows, it's much harder. There's more requirements. Like if you're starting from scratch, the model can use whatever tools it knows or has memorized. But if you're working within an existing repository, you have to think about terms, or like you have to use the tools that the repository is already using. So fitting within that. So instead of creating a file, you have to know where to put that file, for example. There's cascading changes. You have to continually be indexing. Generally, like agents are online probabilistic long-running async tasks, which is kind of it is an inherently complex system. And then the usual cost, arbitrary inputs, and more. Sam touched on this, so I won't spend too much time here. But like starting off, like really focus on one workflow at a time and using this routing layer has been super helpful. And similarly, start with a small toolkit. Like instead of giving the agent everything, really give it one tool or a few. See where it breaks down, like what can't it do, and then gradually kind of increase it. So that's why I started with this kind of closed-end problem of like, okay, let's get really good at navigating a repository before introducing external data sources. It's also kind of fun to be the agent. Like if I had this toolkit, like how would I do it? It's useful for thinking it through. I've also I don't know like if there's a better term for this, but I've been calling it checkpointing. So it's like you have this very focused action agent, and the end state for one agent is a starting point for another agent. And then between each checkpoint, you have a success metric or model that makes a decision about what to do next. Do you continue? Do you stop? Do you prompt the user? Like asking for help. I think there's a ton to explore there about like basically follow-up questions for people. What do I as the agent need to complete this request, or even retrying? And then, like I was saying before, I really think if you're focused on creating less work or like helping people move faster, you don't want to do the wrong thing. And it's also pretty cool to make these checkpoints useful. So if you can like just share your interim progress, like, oh, I found these relevant files, I found these relevant issues. This is the code owner you should talk to. That is useful even if you can't complete the request end to end. And then also explaining that progress to the user. Yeah, I think human in loop, there's a lot of interesting stuff on like the infrastructure of like how to do that well and make that kind of clean. And then
Devin, one question I have around the chain of agents. Like, is that sequence, like, how's that sequence determined? Is that like preset by you? Do you have another agent like determine that sequence?
Yeah, it's another agent that's determining the sequence. So basically it's like, you create a plan, and then each of those plans or tasks like will often correspond to like another kind of execute. So I guess it's a bit recursive. So there's a planning agent, and then so if there's a specific task, the first one that it will be like, okay, is like this search agent, essentially like finding the relevant files. And then once that completes it, then it's like, okay, here are the files. Next is like, okay, what information or changes do we need to make to these files related to this request?
And so this is like very, very related to some stuff we actually put out today in LangChain called plan and execute. So I think, yeah, similar ideas. I mean, so I have a lot of questions that are top of mind.
Yeah.
So like, do you revisit the plan at all? Or do you like keep the plan kind of like fixed?
Right now it's fixed, but I think, and the goal is to change that and like revisit it. I think this like knowing when to stop is a tricky problem. And I think what I've seen from like other kind of auto GPT types is like, if you keep revisiting the plan, you can kind of get kind of stuck in a loop.
Yeah.
So starting with a finite plan has been helpful as like, can you, given this like initial plan, get through it? But I think the goal is to revisit it as you get more complex, especially if you can do this human in the loop, right? So given, I think exactly what Sam was talking about, like given this new information, how would I change this plan, and then continue?
Yeah, interesting. And then when you plan, do you plan like, this is what you should do, and this is the agent that should do it, and say like, like you can pick 5 agents, you like is the prompt like you have 5 agents, come up with a list of steps to do and the agent associated with each step, or does like the figuring out which agent come later?
It comes later.
Okay.
So that's like one thing. I'll just jump ahead a little bit, but I think there's a lot of interesting. I think this is also specific to the task I'm trying to solve, where you have a lot of non-internet data that you're trying to navigate. So it's like there's really interesting search challenges. But one thing that I found was pretty important is like, this is the who, what, why of like who you are as like in the system prompt, what the agent is pretty common, like like in terms of like that standard. I was pretty surprised that the where is really helpful. Like situating, especially when you're thinking about navigating a repository, like here are the, you're in this directory and these are the files in the directory, as like part of like, when to, or like you're in this repository, here's a summary of the LangChain repository and its goals, and here are the components. Kind of situating the agent, I found has been very helpful for just getting better, like both generative, like synthetic data, and also just better like decisions.
So this is more like a hypothetical thing, but one thing that I worry about when like just planning out the steps without thinking about who the agents are is like maybe the agents you have available depend, like that influences the steps you should take.
Right.
So have you thought about that at all, or?
Yes. I think that's the way that works currently is basically there will be things in there that is like, I'm trying to think of an example one, but like, oftentimes the agents, like the starting plan will be very generic or high level. And I guess the choose agents often just ignore those right now. It's kind of like whittles it down. So if there's like one is like research, what is LangChain, or like or something like or what is, I don't know, but like something that is kind of out of the scope of the agents, it's currently just ignored, which sounds bad, but it actually helps simplify the problem a bit when they're coming up with these very kind of like higher level plans. And I've iterated on like different prompts to keep the plans a bit more concise and focused, but still working on that. And maybe just giving it like, here are the things you can do up front will improve that. Yeah, I guess a little bit on search, but this is a little specific to this kind of closed ecosystem problem where you can't just use Google for everything, or like GitHub has search APIs, and you can use other kind of code search tools. But one thing that's kind of interesting about this is, and I do think is really important, is the user request is not a prompt, or it's not even a query, and so you have to kind of map that to something that can then be used to search a repository. And the nice thing about searching with agents is that usually kind of search for the past 20 years, when you're really focused on humans, getting results for humans, you want there to be very few results and them to be come very quickly. But agents are a lot more patient than people, and can do a lot of things in parallel. So you can iterate on the query. So it's been like kind of, I think it's like a slightly different problem, which is and slightly easier because you can kind of take your time with, if you're able to kind of make the information easy for the agent to navigate. The first query doesn't have to return the exact right results if you're thinking about just like similarity search. Yeah, and like similarly, like in this navigation, like you end up building a knowledge graph for any of these. Like, how do you relate things between each other? They can be, this is not new, like PageRank is a perfect example of this, but the links can be LM generated topics, components, or structural, like files on a PR and relating a PR to files, or an author of a commit, or actually navigating the abstract syntax tree. And then I've had a ton of.
What do you mean it helps the agent navigate exactly?
Basically, like in the search context, like you get
in the search context. Okay.
Yeah. Exactly. So, and then another thing that I've had a ton of success with is like basically like synthetic data. So there's hypothetical document embeddings, which LangChain supports. But basically, you take this feature request or question, and you generate variations of it. So maybe like, hey, format this like a Jira ticket or a customer support ticket. Hey, format this like write a bunch of questions about this, and then use those for searching. And then similarly, when you're actually indexing the repository, one kind of cool almost side effect of this is you end up building like kind of it's almost self-documenting the repository to make it easier to map natural language from people that don't understand code or the context of the repository to code. Like if you don't know LangChain terms, you might not write a issue that uses the right terminology, especially if you're asking questions. So you can like come up with, given a file, what are questions that might lead someone to look for this file, and actually generate those on index time, embed those, and then use those to try find the files. Has been really helpful. And then also reflections. So given kind of a series of changes, what is kind of, and like what is a higher level for those people who have read the generative agents paper, like what is like a higher level thought or observation based off these changes, and then kind of reference the original events back to that reflection. And yeah, that's it.
Awesome. We'll jump right into. Let me figure out how to add everyone back to the screen. All right, we're gonna jump right back into questions now. Sorry, I'm still trying to figure out the stage thing. There we go. All right. So and yeah, so if people have questions, add them in the question box on the right. We're just going to go down in order of popularity based on upvotes. So the first one is, I am still struggling to distinguish between single agent multi-tool architecture versus multi-agent architecture. Are there any resources y'all recommend or understand this, particularly multi-agent chains that aren't hard coding in the agent order? I could take a quick stab at this and then because I think, but curious to hear your take on this. I think basically you treat kind of like agents as tools. And so you have some type of like stacking going on. And then you have like a planner agent that says, use this tool, but that tool is really an agent. And so use this tool / agent here, use this tool / agent here, and decide stuff based on that. And that's opposed from just having like one, and that's opposed from just having the tools be like not an agent and be dumb tools like API calls or something like that. Is that correct? I know Sam and Devin, you guys had both mentioned multi-agent stuff.
Yeah, for me, and I see some other questions about the info, so answering that. Yeah, for me, it's very much like the top level router agent has like programs, kind of similar to what you were saying, like programs that we knew ahead of time that the user would repeatedly do, and it's kind of choosing between those programs that have tools that are specialized for that program to route into that direction. We also did some things with kind of, we would treat the main router agent as kind of the orchestrator. So if there was like a need to ask for clarification or like the program stopped, it would return back up to the user and the main router agent and kind of deal with that as a new input. And so that was kind of our architecture, kind of like one top level routing agent that also had a conversation. It was more like a conversational flavor. So like would talk to the user. And then on top of things that were more like the traditional MRKL agents that were just going to pick like a tool to use that was like maybe an API call.
Cool.
Yeah, I think just to add it, like I think of agents as a tool that is just better at dealing with ambiguity, which is necessary. Smarter tool.
All right, next one is a big one that I've heard. The biggest obstacle to getting the agent in production is the speed. Agents are powerful but slow down the response time. What are some good approaches to accommodate this? 2 ideas that are thrown out are 1, run agents in parallel, 2, stream outputs of the intermediate results so users can have a better UX. How do all of you guys think about that? Div, do you want to start with this maybe?
Yeah, I think even for day one, I think we've been thinking like how do we make it really snappy and fast. So I think we use a lot of tricks like streaming, Also, I think we're trying to do like some sort of like caching. So we could cache some LLM calls if they're similar to what a user has done before. Then instead of calling GPT-4, we can just like load it from a cache. And also like GPT-4 can be a bit overkill because it's currently too slow. And I think like you can have maybe like some like custom models or like smaller models that are like much more faster.
Cool.
Yeah,
Devin,
I would say we streamed everything, and we made an early change to the callback manager when we're using the LangChain formulation, so that the callback manager inside any sub agent or the top level agent, for all thought, action input observations would go to a WebSocket. So basically, and back to the user. So like the user could see everything that was happening, and that was key to the user actually being able to add feedback and drive the agent and the thing that I showed, and also made for a better user experience. We also early on did multi-action outputs, so changed like the thought action input thing to be able to do multiple actions at a time, and then like parallelize the execution of those, so that you could do like, if we knew you wanted to check your schedule, check the user's calendar preferences, and like look up something else, all of those could be executed in parallel and then processed in the next loop of the planning cycle.
Yeah, I think caching smaller models or like and parallelizations are like obvious ones. In my case, like I picked a product that can be done in the background, and so also like thinking about what you're benchmarking against, like this has to be better than what it would take like an engineer to respond. So which might be could be 30 minutes, an hour, many hours, depending on how bottleneck the team is. So if it takes like 5 minutes, 10 minutes, that's actually fast in this specific case.
and since you mentioned models, I'll just throw in another question. What models are you guys all using? Is it GPT-4 all the way? Is it some blend of 3.5 and 4? Yeah. Maybe reverse order, Devin?
3.5 and 4 right now. Just basically 3.5 for pretty much most things except for the last stage of like, actually synthesizing. Basically, the synthesis stage is GPT-4.
Sam?
Yeah. I will also say like 3.5 and 4. 4 is really good at planning and like reasoning, and 3.5 is just like good for like smaller tasks where you don't really care about too much complicated stuff. And we can also like we are very interested in using like fine-tuning tricks like LoRa kind of thing, which you can fine-tune a model really fast. And now there's like so many open source models out there.
Use 4 for pretty much everything. I found that especially for the planning and that 3.5 just like wasn't smart enough. I think that changes a little bit if you get more descriptive with the templates. So the more like just help you can give it with kind of like, here's how you should approach this task. You can try to get 3.5 to do it, but you probably just need to test on your own use cases.
Related to that, few shot examples or zero shot, where for all of them? Sam, since you mentioned kind of like examples.
Yeah, I ended up doing zero shot pretty much everywhere. I found that with like, again, this is somewhat qualitative, but after 3.5, I found that like it was much more likely to follow really well spec'd out instructions, and an example may like over specify one particular case. So I just tried to be very, very concrete with the instructions.
Div, few shot examples or zero shot?
I would say few shot helps in specific cases, especially if you have some websites which things fail or you want to have like some very custom behavior. Especially personalization, I think in context examples help a lot there.
Devin?
For me, it's mixed. For a lot of the 3.5 use cases, it's few shot, and then the GPT-4 or zero shot.
Cool. Next question is about the routing. So I think it's again asking kind of like routing agent between different agents as tools, but I'm going to pivot it a little bit and like, how do you do the routing? Is that asking a language model to do the routing? Is that embedding based? Is what's going on under the hood? I know Div and Sam explicitly mentioned routing, and then Devin, I'm not sure if you have routing in it, but maybe we can start with Sam and go that way.
Yeah, for rerouting the model itself. So asking the model like which program to follow, and it has like the templates and the product flows as tools. And so like the tool execution flow looks like kicking off another agent as a background celery process, and then like saying that it did that to the top level agent.
Div.
Yes, I would say like for us, for a lot of things we can just use like the ChatGPT plugins as the routing tool. So we can just use it for free, and also is using 30-day model, so which helps a lot. And I think like the context length helps a lot, especially if you're using a lot of tools, because the router has to understand okay what each tool does specifically for which to choose. And I think like you just need like bigger context length models, which are cheap for this to work well. Yeah.
Devin, anything to add?
Nothing to add. Also, language model for routing.
Next one I think is interesting. Would love to hear your testing strategies, as the outputs are non-deterministic and can't use traditional unit testing. Yeah, this is another big thing that's popped up. So maybe reverse order here. Devin, what do you do for testing?
Ooh, I mean, there's obviously a lot of manual testing, more than I'd like, especially because there's a cost associated with it right now. The nice thing, again, I picked a problem domain where there's a lot of test data available publicly. You know, like I'm able to go to the LangChain repo and cross-reference the files that closed issues versus the files that I found. I'm able to kind of pick examples online that I can use as heuristics. But unit testing, I mean, a unit test functions, but within like the LLM parts, there's not a lot.
Div?
Yeah, I also like worked a couple of years in autonomous driving, and it's a similar problem where you're trying to replace a human with a autonomous car. And I think what has worked there is like having a lot of automated testing, benchmarks. People have built like simulators or even ghost towns where just like crash like cars into mannequins and see like how many % of the time it doesn't like kill a mannequin in a sense. So I think you need to build a lot of this like automation testing in ULs. And I think like currently for us, it's just like very expensive. If you're especially using GPT-4, you'll just burn all the money on like just testing instead of the actual users. So I think currently I would say a lot of manual testing, but we are like trying to get into like a lot of automation testing.
Sam?
Yeah, we wrote like a script that we use. It's not really like unit tests as much as integration tests, but basically like there's specific product flows we're trying to support. And so we would basically mock out like some of the API requests and be like, okay, like assuming that like this returns like some calendar events and like the user is trying to do scheduling tasks, like here's a set of like 10 inputs that would be like reasonable scheduling task inputs. Let's run the agent workflow for each one and see like the side effect is what we'd expect, to the level of detail for which we can expect consistency with the agent. So for example, if the agent picks a name for the calendar event, maybe that's not going to be the same between the two. So you don't want to do equality on like the calendar event name, but you can do a side effect that the calendar event was created with the right time. So like deciding like what the level of consistency between executions you want for your agent, and then potentially doing some type of like integration test suite. And again, as Devin and Jim said, this is expensive. So it's like something we would do after changing a fair amount of the infra, or like doing like a new template format. We try to like come up with like 10 to 15 inputs. You can use GPT for that. And then basically like run the suite of integration tests to see if anything broke with the change.
All right, we're gonna wrap it up there because we're out of time. Thank you guys for coming on and joining and sharing. There's actually a lot more questions, so I'm sure if you guys wanted to drop your Twitters maybe or something in the chat, I'm sure a lot of people would love to follow up on some of this stuff. Yeah, thank you guys for joining and sharing everything, and thank you everyone in the audience for joining and asking great questions. So see you at the next one.